Okay, welcome back to the second day of section 4.1, where we are looking at inverse variation and the reciprocal function in algebra 2. For our warm-up today, I'm going to have you try a problem like we finished with yesterday. In an inverse variation, x equals 8 and y equals 2, write an equation that represent the inverse variation. Find the value of y when x equals negative 4. So go ahead and pause the video and then push play to see how you did. Hopefully you figured out that your k was 16 and that when you plug that in and divided by negative 4, you got y to be negative 4. So you should have had when x is negative 4, y is negative 4. Okay, today we're going to start to look at the graph of the reciprocal function. And the reciprocal function is y equals 1 over x. So this is going to be considered the parent function. So we're going to spend some time figuring out some key characteristics of this, and then we're going to talk about how to shift it based on some other stuff we've already learned this year. So step 1 says consider the domain and range of the function. So when I think about domain, the first thing I think about is that it's all x values. Without the graph, when I think about what x values it can have, I look at the equation and I see that I'm dividing by x. So really you're asking yourself, what numbers can I plug in for x and do 1 divided by that? Well, I can plug in negatives, right? 1 divided by negative 5 is negative 1/5. I can plug in decimals. I can plug in positives and positive fractions and decimals. The only thing that I can't plug in, though, is 0, because I know that 1 divided by 0 is undefined. So the domain is all real numbers, except x can't be equal to 0, but it can be everything else. Sometimes you'll see this in set notation, and it'll look like this. It has the x such that x can't equal 0. Okay, but for my purposes, if you just want to write x can't equal 0, that's great. Okay, so no matter what I plug in, I can never plug in 0. And then if I think about the range algebraically, that's the y values. So then I think about all the values that I do plug in. Well, if I plug in negative numbers for x, I'm going to get negatives. If I plug in decimals and fractions, it just changes. I can plug in positive numbers and get positive y values. But again, if I can't plug in 0, then I'm never going to get 0 as an answer. So it's the same thing. Y can't equal 0 for the range. Again, in this set builder notation, it would look like this. Okay, so I know that x and y can never be 0, but in theory, everything else is covered. So when we look at this graph, if I do build a table to graph it, 1 divided by negative 3 is negative 1/3. 1 divided by negative 2 is negative 1/2, negative 1. Remember when I divide by a fraction, then I have to multiply the reciprocal of the denominator. So this would actually give me negative 2, negative 3. Remember, 1 divided by 0 is undefined. This would give me positive 3, positive 2, positive 1, positive 1/2, and positive 1/3. So if I build that table and plot those points, at negative 3, I have a point at negative 1/3. Negative 2 is negative 1/2. Negative 1 is 1. Negative 1/2 is negative 2. Okay, so I get those points. I have to skip over 0. So I'm actually going to draw on a dotted line there. We'll talk about what that's called in a second. And then at 3, at 1/3, I have a point at 3, 2, 1/2, 1, 1/2, and 3. Okay, because this line is a dotted line that it never touches, it actually creates these two separate pieces for the graph 1 over x. Okay, so this is actually what the graph looks like. But remember, it can never touch y equals 0 either. So there's actually going to be a dotted line there as well. These two lines are going to be very important things that we'll talk about in just a few slides. Okay, so this is the graph of y equals 1 over x. Let's continue to explore what happens with this graph. So with the same thing, we're going to observe the graph of 1 over x as it approaches positive and negative infinity. So we're still dealing with the table. Again, if I do 1 over 1, I get 1. This will give me 1/10, 1 100th, 1 1,000th. Isn't it true that the bigger x values I plug in, it's actually getting smaller and smaller and smaller. So as x gets larger, the function, so f of x, gets smaller and smaller and smaller, but it gets closer and closer to 0. Okay, so it gets closer and closer to 0, but will never actually reach 0. Okay, because again, I can't get to 0 because it's 1 divided by 0, which is actually undefined. Now, if we want to use our fancy math notation, this goes back to some stuff we did last chapter. Remember, we can write as x approaches infinity. That's what's happening here, right? As x keeps getting bigger and bigger and bigger and bigger, f of x, the y values, approaches, and again, it's getting closer and closer to 0. Okay, so as x approaches infinity, f of x approaches 0. That's what we learned by looking at the table. Now, if we go back and look at the graph, once again, we're talking about as x gets bigger and bigger. We're looking at this highlighted right-hand side of the graph as x approaches infinity, and we can see that it's getting closer and closer to 0, but it's never actually touching it. Okay, so now let's look at some other things. So with this slide, we're saying observe the graph y equals 1 over x as x approaches 0 for positive and negative x values. Okay, so once again, we're going to build our table. So 1 divided by 1 is 1. 1 divided by 1/10 is 10. This would be 100, 1,000, and 10,000. Okay, so remember, we're going from 1 to 1/10 to 1/100th. So x is getting closer and closer to 0. So as x approaches 0, f of x approaches, and let's look at what those f of x values are doing. Okay, 1, 10, 100, 1,000, 10,000. These are getting bigger and bigger and bigger, and they're going to get bigger and bigger forever. So we say that that is going to infinity. Okay. All right, if we do the same thing for negatives. So we go from -1, that would be -1. This would be -10, -100, -1,000, -10,000. So these are actually getting smaller and smaller and smaller. So so this is for positive x values. Okay, so that's going to be something, the direction is going to be important, but this is for negative x values. So as the negative x values approach 0, for negative x values as x approaches 0, f of x is going to go to negative infinity because they're going to go down forever and ever and ever. Okay, so what that's talking about, if I go back to the graph, we said as x approaches 0 from the positives, that's these, right? So as it's getting closer to 0, it's going up forever, so up to positive infinity. And as x approaches 0 on the negative side, you can see that that part goes down forever. So those are the two parts we're talking about when we look at the graph. Okay, so now that we look at all of this, again, we're seeing that these key spots are approaching these dotted lines that I said were going to be very, very important. Those are lines that it gets close to, but it doesn't actually touch. And they have a special name. They're called asymptotes. So I would get this in your notes. An asymptote is a line that a graph approaches. Asymptotes guide and behavior of a function, and we kind of referenced that already. Again, if we're talking about y equals 1 over x, we said we have this special dotted line here and this special dotted line here. And our graph looked like this and like this. Okay, so end behavior, remember, circle the far right. This was as x approaches infinity. I'm going to say y this time approaches 0. Okay, it approaches that dotted line. We didn't do this one, but as x approaches negative infinity, now I'd be looking at this arrow, far left side, and we can see that that is also approaching that line at 0. So that's this piece right here, that asymptotes guide and behavior of a function. Okay, but this right here is an asymptote. Specifically, it's going to be a vertical asymptote. And asymptotes are vertical or horizontal lines, so they need to be equations of lines. So this is a vertical line at x equals 0. Okay, so don't just say 0. It's actually x equals 0. And this is another asymptote. It's actually a horizontal asymptote. And so because it's horizontal, it's going to be y equals 0. So those are the key characteristics of 1 over x. Now every once in a while, you're going to see that number on top change. So if we changed it to 10 over x instead of 1 over x, we can still think about our domain. Nothing's going to change the domain and range. Okay, I still can't divide by 0, so my domain is still that x can equal 0. My range is still that y can equal 0. Which means then that there is still an asymptote, so it's a vertical asymptote, at x equals 0. And there's still a horizontal asymptote at y equals 0. Okay, so those two things don't change. I draw those in. I'm going to talk about what does change those in just a second. Now I could make my table again, just to see what that 10 on top actually does to it. So if I plug in -1, I get -10. So that puts a point way down here. If I plug in -10, I get -1. So -10, -1. And if I plug in like a -2, I actually get -5. The reason I show that, and I could keep plotting point, oops, that's terrible drawing. Okay, it looks like this. Again, I could do the positives, 1 or 10, 1 and 2. I get 1, 10, and 5. So 1, 10, 10, 1, and 2, 5. So again, you can always plug in some values. Here's the thing. If all that's changing is that number on top, it doesn't change the asymptotes at all. It doesn't change the shape. I guess it kind of does, but what it does is it changes this size, or the space between the asymptotes and the curve. Okay, so if the only thing that changes is the number on top, you're just going to make this table to find a few key points to make sure that it goes there. Okay, but more importantly, probably, is what is going to actually move those asymptotes. And this goes back to some rules that we already learned. Okay, it says the function q of x equals 1 over x minus h plus k. It's a transformation of the parent function f of x equals 1 over x, and it's going to follow these rules. Here's the key, you guys. The rules don't change. We have learned multiple times this year that if something is grouped with the x, it moves it left or right because it's the opposite of what you'd think, or it moves it left and right, the opposite of what you would think. Okay, and it moves it left and right because it's with the x. It's changing the x values. So when I see that x minus h in the denominator with the x, that is considered grouped with the x because it's in the denominator of the fraction with it. So get this written down. Adding h to x in the definition translates the graph left or right the opposite of what you think. And again, that's because when h is in the denominator with x, it's considered grouped with x. Just like before, when it was in parentheses with the x, it was considered grouped with the x. It was the left or right opposite of what you think. And then the other piece we see here is the x, or the plus k value. Now that is being added or subtracted, but it is not grouped with the x. So as we've learned all year, if it's not grouped with the x, it affects the graph vertically. So that plus k value, adding k to f of x, translates the graph of f up or down. And remember, that's always the same as what you would think. Okay? So if we're adding numbers to the x and or on the end, it's going to be shifting the graph left, right, up, and down. It's the translations that we've learned before. Now you can think about it. If I have a vertical line and I move a graph left and right, it moves that vertical line. So this part, if I move it left or right, that's going to move the vertical asymptote. If I take a horizontal asymptote, move it left and right, it doesn't change it. But if I take a horizontal asymptote and move it up or down, that's going to change it. So this is going to move the horizontal asymptote. So let's look at what we mean. Okay, so if I ask you to graph g of x equals 1 over x minus 3 plus 2, first ask yourself, what are the equations of the asymptotes? What's the domain and range? Draw on those asymptotes and then sketch the rest. Again, I'm going to look first at the x minus 3. And I'm going to say that's grouped with the x, so it's going to move it left or right, opposite of what you think. So the minus 3 is actually going to move it 3 to the right, which means it's going to take that vertical asymptote that was at 0 and move it 3 to the right, so it's actually going to be at x equals 3. Now this is saying write the equations of the asymptotes. I got that, and the domain and range. Well, if there's an asymptote there, then the domain is x can't equal 3. So these two things go hand in hand. Now the other thing I see in this is the plus 2. Plus 2, it's not grouped with the x, so it's going to move it up or down the same as what you would think. So you're going to take this whole graph of 1 over x and shift it 2 up. Again, if I take a horizontal line and shift it up and down, the horizontal line is going to shift up. It started at 0, so now my horizontal asymptote is at y equals 2. That will affect my range. My range then is y can equal 2. Again, these two things go hand in hand. Drawing my horizontal asymptote at y equals 2. Okay, so anytime I graph a translation of the 1 over x graph, I move my vertical and horizontal asymptotes first. And then I just plug in a couple more points. So in this case, I'm going to plug in 2 since it's right next to the asymptote. I plug in 2, I get 1 over 2 minus 3, which is negative 1, plus 2 is 1. So there's a point right here. And then I know it follows along the asymptotes. Okay, so that's enough to sketch this graph. I'm also going to check 4. 1 over 4 minus 3 is 1. 1 over 1 is 1. Oops. Plus 2 is 3. So there's a point at 4, 3. And again, it's along those asymptotes. Okay, so here it was looking for the graph. That would be sufficient, and it's looking for this information. Okay, last but not least, I want you to try one of those on your own. Again, I would start by asking myself what translations are happening, and then write your equations of asymptotes and how does that affect the domain and range, and sketch a graph. Pause the video, try that, and then play it to see how you did. Okay, so hopefully you saw that the x plus 2 would make it go 2 left. So your vertical asymptote moves 2 left, which is at x equals negative 2. I drew that in. The minus 4 shifts it 4 down. So the horizontal asymptote moves 4 down, which means it's at y equals negative 4. Again, if my asymptote is at x equals negative 2, that means the domain is that x can't equal negative 2. If my asymptote is y equals negative 4, then the range is y can't be negative 4. Okay, so I drew in those two asymptotes, and then I tested 2 points, one on each side of the asymptotes, plotted them, and drew my sketch. To summarize what we did this section, first we started by talking about inverse variation. You can see some of that on the left-hand side, and we ended today by talking about transformations of this function. Those are the keys you want to take away from section 1. You can now move on to your Pearson practice for section 4.1, day 2.